Inside the shadow of Geneva, under the world's floor, lies a shock of human creativity and a harbinger of decimation. The beastly Hadron Collider. It is a manual of canny evaluation, permitting specialists to break down the subatomic and activating the discovery of the puzzling God particle, the Higgs boson. As of now, renowned physicist Brian Cox has made a chilling declaration that sent shockwaves through the philosophical community. Something concerning has been examined, something that might have far-reaching consequences beyond our comprehension. Has our primary objective for illuminating scientific discovery set us on a crash course with disaster, obliging us as we plunge into the depths of this clear problem? Before we dive into the details, what is the Large Hadron Collider, LHC? Built by CERN, it is a 17-mile ring of superconducting magnets and the world's most powerful particle accelerator. It represents the pinnacle of human scientific achievement. The collider can replicate the actual conditions of the universe's creation. But should this machine aim to uncover the universe's inner workings, we must remain aware of the potential consequences that could be far more disturbing. CERN, established in 1954, is one of the world's most prestigious research organizations, with 23 member states and a large global team of specialists. It is a center for collaboration and innovation. The LHC is CERN's focal project, but it is just one part of a vast network of accelerators. These tracks for subatomic particles are a race toward the very essence of existence. The LHC speeds up protons to nearly the speed of light, sending them on a collision course that mirrors the energy of the universe at the time of the Big Bang. The resulting collisions create temperatures 1,000,000 times hotter than the center of the sun. An immense array of magnets guides the protons on their journey, while advanced cooling systems protect the magnets at temperatures colder than outer space. These include 1,232 dipole magnets, which bend the beams, and 392 quadrupole magnets, which focus the beams just before impact. Another notable type of magnet is used to compress the particles closer together, increasing the likelihood of collisions. The task of CERN is to achieve precision, like joining two needles 6 miles apart with such accuracy that they meet. The required precision is astonishing, and the LHC's design is a marvel of engineering. It incorporates ultra-precise support beams that stretch deep underground, shielded from cosmic radiation. In this underground global facility, the entire system is cooled to a temperature of 46 degrees Fahrenheit, colder than the vacuum of space itself. This cool environment is essential for the superconducting magnets to function optimally. The collision points in the LHC are designed to occur at 4 locations across the accelerator ring, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each has a unique focus on investigating different aspects of particle physics. Collectively, they act as colossal cameras, capturing images of these collisions. Specialists then sift through the debris, searching for signs of the elusive Higgs boson, also known as the God particle, a key to understanding the universe's fundamental structure. It's like solving an enormous jigsaw puzzle where the pieces are obscure and the picture is difficult to grasp. By focusing on the microcosm, we gain insights into the universe. But with each answer comes another question, and with each discovery, another challenge. The LHC is not just an instrument of scientific inquiry. It is a manifestation of human curiosity, ingenuity, and ambition. It embodies our quest for knowledge and our desire to understand the fundamental forces that shape our universe. As we stretch the boundaries of our understanding, we must also consider the moral and existential questions that arise. What are the risks of exploring the unknown? Could our pursuit of knowledge accidentally unleash forces beyond our control? Inside the hallowed halls of CERN, where the frontiers of human understanding are continually pushed, a discovery has emerged that sends a chill down the spine of even the most composed scientists. Brian Cox, a former researcher at CERN and a respected voice in the field of particle physics, recently made a statement that has left the community both captivated and alarmed. Cox's words resonate with a troubling possibility. The goal of CERN's Large Hadron Collider is to recreate a miniature Big Bang. Indeed, you heard that right, a smaller version of the very event that brought our universe into existence. The physicist also highlighted the potential consequences of this goal, mentioning the LHC's extraordinary capacity for creating new phenomena. This includes its potential to unlock the secrets of the Higgs boson and the study of dark matter, a substance that makes up a significant portion of the universe. Consider the prospect of coming close to discovering the very fabric of the universe. A tempting opportunity, but one fraught with danger. The miniature Big Bang is not just a theoretical concept. It is a tangible reality within the LHC. The temperatures, pressures, and sheer energy involved all replicate the conditions of the universe's earliest moments. It is like watching the dawn of existence itself. However, with such power comes great responsibility, and the question arises, how far is too far? Consider what could happen if something went wrong. Back in 1978, Russian physicist Anatoly Bugorsky experienced a mishap that fundamentally altered his views on life. While working at the U-70 synchrotron at the Institute for High-Energy Physics in Prodvino, Russia, a malfunction caused his head to accidentally intercept a proton beam. The beam, carrying an enormous amount of energy, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's vision was immediately affected. He saw a flash brighter than 1,000 suns, yet he felt no pain. The path of the beam left a trail of destruction, burning tissue and bone, yet he remained conscious and even walked to the hospital for treatment. The incident was both shocking and fascinating. The beam's impact caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, remarkably, Bugorsky survived and continued his scientific work. This incident is not just a personal tragedy but a cautionary tale that highlights the immense energy and potential danger of particle accelerators. The risks associated with a particle accelerator like the LHC are not to be taken lightly. The potential for unpredictable reactions, the manipulation of the very fabric of reality. These are not the stuff of science fiction, but real concerns voiced by some in the scientific community. The LHC's experiments are not just tools for discovery. They are instruments of immense energy with the potential to change the world, for better or for worse. One of the most significant fears associated with the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, lurking in the shadows of our universe. The idea that the LHC could create such an object, even on a small scale, is alarming to both laypeople and scientists alike. Should this black hole grow uncontrollably, consuming the Earth from within? However, scientists at CERN have assured the public that any black hole created would quickly evaporate, posing no threat. Nevertheless, the debate is ongoing, and the fear is real. The power we wield with the LHC is awe-inspiring, but it also comes with significant risks. Understanding how the LHC could create a black hole has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy involved is so immense that it distorts the very fabric of spacetime. Imagine a trampoline stretched tight, and then a massive weight dropped onto it. The surface warps and bends. Now, if the load were heavy enough, it could create a tear so significant that anything nearby would be pulled into it. This is an extreme analogy for what could potentially happen in the LHC. In the realm of quantum physics, where the rules of the universe are both strange and mysterious, there exists a theory that additional dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could exploit them, creating a gravitational well that forms a tiny black hole. This intriguing dance of science and speculation has even caught the attention of some very famous scientists, notably the late Stephen Hawking. In his book, Hawking warned of a scenario in which the Higgs boson could become unstable at extremely high energy levels. This instability, he suggested, could cause a catastrophic vacuum decay, an event that would not only destroy the Earth but the entire universe. British astronomer and astrophysicist Sir Martin Rees voiced his own concerns about the experiments conducted at CERN. In his book, On the Future Prospects for Humanity, he discussed the potential dangers associated with particle accelerator experiments, including those at CERN. His words were not merely cautionary. They were tinged with an existential dread. He mentioned the direst possibility where an ill-fated experiment could create a situation known as vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of spacetime, with disastrous consequences for the entire universe. Ries's concerns were not limited to theoretical musings. He devoted a chapter to these terrifying possibilities. While he considered the probability of such catastrophic outcomes to be low, he argued that even a small chance should give us pause. When the stakes are unimaginably high and the margin for error is razor-thin, caution is not merely advisable, it is essential. The scientists at CERN have considered the potential risks associated with their experiments carefully. They have implemented numerous safety protocols and precautionary measures to minimize any potential hazards. But the nature of scientific exploration inherently involves some level of uncertainty, particularly when venturing into uncharted territories. The quest for knowledge has always been accompanied by a degree of risk. From the early alchemists to the pioneers of nuclear physics, the pursuit of understanding has often been fraught with danger. But it is this same pursuit that has driven humanity forward, leading to discoveries that have transformed our world in profound ways. As we continue to push the boundaries of what is known, we must remain vigilant and mindful of the potential consequences. The Large Hadron Collider is a testament to human ingenuity, but it also serves as a reminder of the limits of our understanding. The story of Anatoly Bugorsky and the warnings of scientists like Stephen Hawking and Sir Martin Rees highlight the need for caution as we explore the frontiers of physics. The LHC is a tool of immense power and potential. It has the capacity to unlock the deepest mysteries of the universe, but it also carries with it a responsibility to use that power wisely. As we continue to search for answers, we must remain aware of the risks and uncertainties that come with it. Science is not just about seeking the truth. It is also about navigating the unknown and balancing our quest for knowledge with the responsibility to safeguard our world.